Okay, so we are going to do some examples from the Ionic Compounds number 1 handout that you picked up today. I'm going to start off by reading the background a little. It says, when a metal and a nonmetal combine, an ionic compound is formed. The metal atom loses one or more electrons, forming a positive cation. So underline metal and cation. Okay. The next thing it says is the nonmetal atom gains one or more electrons, forming a negative anion. Nonmetal, anion. Because these ions have opposite electrical charges, they attract each other and form a compound. This attraction is called an ionic bond. The atoms combine in a ratio such that the number of electrons lost must be equal to the number of electrons gained. The sum of the charges of the ions in an ionic compound is therefore 0. So in our notes, we actually hit upon how to name and use the crisscross method to put the formula in. So what we're going to do is just a little bit more practice so that hopefully you'll get the hang of it and you can do it on your own. So I'm going to start off with the naming because that's the easiest part. In the naming, you're going to look for your metal. Typically that's the first one on the left hand side. So I'm going to look for Na in my periodic table, and if you notice right here, Na is sodium. I'm writing this on a separate sheet of paper. You probably won't need to do this, but I want you to see what I'm saying. The next thing we're going to do is look for our nonmetal, which in this case is Cl, and our Cl on our periodic table is chlorine. Now the first thing that you always write down is the metal itself. Don't have to change anything, just write it as is. Now, when it comes to the nonmetal, we are going to drop the ending, and in this case, I'm going to shade it out. Okay, drop the ending, and we're going to add IDE. So instead of chlorine, we're going to say chloride. Okay, so when we write it out, it'll be sodium chloride. Okay, let's do another one. So we have Al and F. Let me get another sheet of paper so I can cover this up. There you go. So again, I'm going to look for Al on my periodic table. Al is right here. It is aluminum, so I'm going to put aluminum. And again, you can just write it up there. I'm just doing it step by step so you can see what I'm doing. F is right here. It is fluorine. Notice I don't have anything to do with any of the subscripts. It's just the elements themselves. So just like I said before, we're going to write the name of the metal. And then when it comes to the nonmetal, we have to drop the ending. And add IDE. Okay, and that's what you're going to write. So it's going to be aluminum fluoride. Okay, simple as that. And again, metal is going to be on the left-hand side, non-metal is on the right-hand side. Okay? Now, when it comes to formulas, you're going to basically be using your periodic table just like you've been. And you're going to now actually write down the oxidation numbers, or those numbers that we had you put at the top of each column. Okay, those are your oxidation numbers. So I'm going to look for magnesium. Magnesium on our periodic table is right here. It's under the 2+. So I'm going to write it out like this. Okay. I'm going to look for chloride. Chloride is right here. Chlorine, which is under the 1-. Now, what we're doing is we're going to be doing the crisscross. I'm going to show you on the separate sheet of paper how to do this. Instead of writing it all on the paper itself, I'm going to write it on a separate sheet of paper. So this is what it looks like. Now, first thing I have to notice, are these the same number opposite charges? No, drop the charge. Now, some people, you have to really scribble out that charge. That way you don't get confused with it. Next, I'm going to write the metal first, the symbol itself. I'm going to take the number from the non-metal and make it become the subscript of the metal. Now in this case, since it's going to be a 1, I don't have to write anything. It's automatic. Next, I'm going to write the metal, non-metal symbol. And now I'm going to take the number from the metal and make it the subscript of the non-metal. Again, this went straight across and became the subscript of the non-metal. All right, so let's do another one. I have lithium oxide. Twist my paper out so you can get a cleaner look. There we go. Lithium is going to be on the alkali metals, that 1+. Okay, and then oxide, again, is part of the 2- oxygen family. Again, I'm going to write it on the paper so that you can see where these numbers are coming from. So lithium and oxygen. Are they the same number opposite charges? No. Get rid of the charge. Mark it out. Write down the symbol of your metal. And the 2 from the non-metal becomes the subscript of the metal this time. Okay, so we're going to put 2 right here. The 1 becomes the subscript of your oxygen. The number from the metal becomes the subscript of your non-metal. But since it is a 1, you don't have to write it out. So I'm just going to put O. Okay? All right. Let me do one more. Just one more. I'm going to do zinc sulfide. Now, one of the things that I want you to realize, transition metals for right now, for you guys, is going to be a 2+. All the transition metals are going to be a 2+ oxidation number, okay? So we're going to look at zinc sulfide. And the reason I say that is because zinc is located right here, transition metal. So again, transition metals, just put it as a 2+ for right now, okay? I look for the sulfide, which was sulfur, which is right here, and the 2-. Here it goes. Now I'm going to say, are these the same number opposite charges? Yes, they are. Since they are the same number opposite charges, you drop everything and you just write the element symbols. So Zn, S. Okay? Same number opposite charges, drop everything and just write the symbols. All right. Let's get to practicing.